Everyone, welcome to this YouTube video. And in this video, I'll be talking about the out of memory issues that you'll be facing in your Apache Spark projects. And in this video, I'll give you a detailed example on what are the different types of out of memory issues that you'll be facing and how you can mitigate them as well. So without any further ado, let's jump right in. So out of memory issues can occur either in the driver side or in the executor side. And initially, I'll be talking about the driver side out of memory issues. So in the driver side, out of memory issues will arise mainly due to the collect operation and the broadcast variable operation. So in order to explain about this in detail, let me just go and create a diagram for you. Generally, we'll have a driver in our Spark architecture, and we'll have executors. So our driver side will send the our driver will drive the main Spark program, and the executor will execute the task that is created from the tag. And then once all our operations are executed parallelly by the executors, the data will be sent back to the driver. That is the final data. And when you do a collect operation, the data that is being parallelly processed, all of these data will be sent back into the driver. And if we don't have sufficient memory to handle all the output from all these executors, then you will face an out of memory error in the driver side when you're doing a collect operation. So it is better to actually write your output from your executors into a Parkway ORCR CSV file into a storage destination like AWS S3 or whatever object-oriented storage you have in your solution. So this is one type of out-of-memory error that you can face in the Apache Spark. And the next one is broadcast variable issue. So before I talk about this issue, I'll discuss about what a broadcast variable is. Let's say you have two tables, one very large table and a very small lookup table. So what Spark, that is the broadcast variable, does is that this very large table will be splitted across the executors based on the partitions or whatever conditions that we define. And this table, the smaller table, that will be placed inside your broadcast variable when you define it. And that broadcast variable will be present in your driver program that will be referenced by the executor programs when they are doing joins against these tables. So in a way that we are like having a single point of reference for all the executors. And suppose if the broadcast variable table, it is generally a smaller table joining a very large table, but if this smaller table exceeds the memory that is available in your driver, then you will face a broadcast variable out of memory error in your driver side. So these are the main two types of out of memory issues that you will face in your driver side. And coming next to the executor side out of memory issues. The first one is yarn memory overhead. So yarn or your Spark cluster manager that will like manage all the resources in your executor when your driver initiates or submits a Spark application. So what do I mean by yarn memory overhead is that you will have memory for your executor operations and whatever metadata or the objects that you're defining in Spark. If you're not using native Scala or if you're using PySpark or Java, the objects that you will be creating or the data frames that you'll be defining, all these metadata will be stored in your yarn memory. So this creates an overhead, and in case if yarn doesn't have sufficient memory to store all your objects and variables, then you can face an executor side out of memory issue. And the next one is high concurrency issues. So what do I mean by high concurrency issues? So let me just go back to the drawing board. And let's just create an executor first. So let's consider this as an executor. And we'll define the course or the task that you do your processing here. Yes. So we are defining like 6 tasks or 6 cores we are assigning it to our single executor. And like this, there could be multiple executors in your system. And like each and if you increase the number of cores for each executor, what happens is that, like, for example, if you're assigning like 8 cores, or like in our example, it's 6 cores over here. And for each core, a task will be processed in parallel. So what internally happens is that not only the data, like the data that each task will be processing in this core, you have to like think about the metadata associated with each task as well. So if you're defining way too many number of executor cores, then what happens is that sometimes you will face an issue that uh, the cores won't have executor memory to store the metadata that is required for processing. So due to high concurrency, you can face an out of memory issue in your executor side as well. So when you're calculating the number of cores or number of executor tasks, do bear in mind that the metadata associated with it as well. And finally, bigs or skewed partitions. So when you're taking a table or a data frame and you're like dividing that data into partitions, then each executor will have its own partition. Suppose like we are having a users table, and in that we are partitioning based on the country. And we have like 3 countries, that is India, Australia, and USA. And we have a huge number of users in India compared with Australia and USA. Then one executor will be having a huge data when compared with the remaining 2 executors. So usually our data would be in a compressed format, that is in Parquet or ORC file format. And during processing, the executor will uncompress the data. So apart from the metadata, the actual data will also be present in the executor when we are trying to process that. So due to this skewing of partitions, you will face an executor side out of memory issue as well. So how do you solve this? How do you mitigate this type of things? So you could repartition your data frame or database, or you could try to bucket your data based on partitions such that it is not skewed when you're trying to process it. So these are the common out of memory issues that you'll face in Apache Spark, either in driver side or executor side. And this is one of the most frequently asked questions in Apache Spark interviews. And if you like this content, then do comment and share it. And Catch you guys until the next video.